Hi robot makers, how you doing? Hope you've had a good week so far. So, do you want to know how to build PicoCat, which is what I'm now calling OpenCat, in Fusion 360? So let's continue our journey with PicoCat, the open source robotic cat, powered by Raspberry Pi Pico and by MicroPython. So let's dive straight into this. My name is Kevin McAleer. Come with me as we build robots, bring them to life with code, and have a whole load of fun along the way. Okay, let me get over to my keynotes. So yes, this is all about PicoCat. So the goals of this session, if we can get through it, there's quite a bit to do today. It might have to be a two-parter, is to recreate OpenCat in Fusion 360. So we want to create a couple of components there. We've got the shoulder, the foot, the leg, the collar, which is this bit, the neck and the head. And we're going to model this off a real cat. So I've got my OpenCat here. Which is this particular design I took off the internet probably about a year ago. Can't find it since, so I guess it's been superseded. And the newer version has some slight differences, so I've got this newer version here. I think this is a better design. This one requires quite a bit of screwing in and so on. Anyway, let's get back to our model. So what we're going to do is, here's a skeleton of a poor cat that's giving itself up to science there. And what we're going to do is we're going to sort of overlay underneath that quite a crude skeleton structure. And we're going to use standard kind of servos, these SG90 servos, to power the thing. So let's get over to the next one. So I've already modelled some servos, so I'll not be modelling those today. I think I did cover one of those in a previous session, but they're pretty standard sort of dimensions, widths. I think it's 11.8 sort of thick. Just trying to see if I have one to hand I can show you. I've got a box of them just here actually. So let's just open one of these up and I can show you on camera what the actual measurements are. So they come in these little packages. You get some, I call these servo horns. I don't know if that's the correct term, but you get like a little bag full of bits. And you get the servo itself. They're usually this sort of transparent blue colour. So I'll just come back over to the main camera for a second. So I've got my trusty calipers here. They're usually quite accurate. They can be a bit temperamental at times, but if I just measure the thickness of this, and given that it has got, is that right? That's there, and then that's there. So that's showing as, that's not right at all. What's going on there? This playing up. It's gone to inches, that's why. I was expecting to see millimeters. So that should be, it says 12.35. I have them as 11.5, which is quite a bit smaller actually. 11.8. And then that dimension there, which is the kind of cross section that we're interested in for quite a few of these things, that's showing as 22.5. Again, I'll just shut these so you can see it's about 0.1 accurate. So on here, yeah, 23 across is what I've said there for that measurement. I can get that across there. 22.8, 23 is about right for that. And you can see the other various measurements on there on the screen too, if I just go back to the screen. So yeah, 23 across, and then about 24 of the sort of height of the thing from sort of this edge to this bottom edge here. So I'm not going to model those in this session. We're actually going to bring that in as a previous design that I've created in Fusion. It's going to be a bit of a Fusion 360 kind of show today, so hopefully that's what you're up for as well. And I've just managed to sign out of my other screen there, so let me just sign back in. So I've got my notes on a different computer. Okay. Is that going to ask for the full login? Or no, there we go. So I can go back to my notes. Okay, so before I do, hey Uday, how's it going? To see the people coming through on the chat there. So yeah, if you're on the chat, just let me know where you're coming from, where you currently are, and just say hi as well, just so I can see that you're watching there. So I'll not do the like and subscribe bit just yet. I think that's a bit premature, that bit. What we do want to do is go over to Fusion 360. So I have got some other stuff to share with you slightly later on about another robot I found that's 3D printable. I have to show you this. It's so cool. And I am in the middle of printing out my own version of the Otto Smars crossover robot too. So that's not moved on since, was it Thursday that I put that video out about that. So let's get over to Fusion 360, and hopefully you can see that on screen now. If I go to that view there, that should be better. I'm just going to move this screen down so I can see what I'm doing. There we go. Okay. Yeah, perfect. So this is what I built so far. I've not completely modelled everything, but there's more than enough for us to be getting on for this today's show. So you can see there, this is a PicoCat, as I'm calling it. It's based on the OpenCat. I'll have to credit whoever did the original design for this model because it's really quite clever. And you can see all the blue servos there. There's quite a few of them. There's 10 in total. I've not put the one for the tail in there yet, and I've not also modelled the body yet, but you can see the rest of it is pretty much there. The head's not quite aligned correctly at the moment. It's slightly to one side, but I can fix that up as we go. So what we're going to do, we're going to create a brand new version of this from scratch. And we've got the pieces here if we need to just sort of double check any of the measurements. So I've got quite a few of the pieces here as well. So we can sort of measure things if we need to. But I've got my notes just to one side, and hopefully that'll take us through. So like we saw in the keynote, what we want to do first of all is just start with a sketch. I'm going to do this on the front, and I'm just going to create a sketch there. And I'm just going to create a couple of rectangles, and we're going to just start out like so. So there's one for the body and one for each of the leg parts. So, and then what we will then do is we'll sort of make these fixed to the ground so that they're not just floating in space. So I'm going to go from the origin there, just draw a line straight up. I'm going to press X to make it a construction line, and then I'm going to measure the distance of this. So D for dimension, just need to take it off there, D for dimension. And this one is going to be 133.5. That seemed to be the right dimension. I'm not going to give it an actual height just yet. What I am going to do is these are going to be from the ground. So I'm going to make this bottom piece here. I'm going to make that so that it's linear, collinear to the ground, which we need to just draw out a line from there. So let's just draw a line, give that X for construction, grab that line, and then make them both collinear. And that should bring that up there. Okay, so then this bottom piece, which I'm calling the foot, this is 66.5 in height, which means we probably need to move everything up a bit. So if I just grab this, move this up a bit, and grab this, which is going to be our thigh, our leg, as I call it. And then the foot, just to give that an internal dimension there. I'm going to give that one 18.5. Okay. So that's going to be this piece. Where are we? This piece here. This is the leg. This bit with the sort of nice bit of a paw on it. I'll just come to the full screen for a second so you can see this. So the leg I've modelled here in its entirety, and we have the servo, and there's a pivot point that's going through that. And we're going to use things like joins to make all this articulated and jointed together. And that's going to be quite an important part. So we need to know exactly where those points are so this whole hangs together. But this is a kind of a bottom-up, top-down approach mixture. So top-down because we're starting with this overall picture, and then we're going to go bottom up by getting into the actual detail of each of these as we go. So this piece here, if I just bring this out, that is 68, and I think it's 21 across, just slightly bigger than the other one. Okay, and these are going to overlap, and they're going to overlap where that pivot point is. So let's just put some circles in here. So I'm going to create a circle, which is going to be, if I just create a circle over here for a second, and I'm going to make it tangential to the top of there, like so. I'm going to make this edge tangential to there, this edge tangential to there, and then we've got a nice little rounded piece because these pieces are rounded on the top as well. And what the most important piece on here actually is like a 45-degree angle, because if I show you on the main cat here, this angle here is pretty much 45 degrees. So that is going to be, you know, the bottom piece that we have on this rectangle is going to be across here, and this is going to fit within that rectangle that we've already drawn. So it'll all come together shortly. You'll see what we're getting at there. So I just need to draw from this corner here just an angle, and then I just need to do D for dimension on that bottom piece and make that 45 degrees. Okay, and we're going to give it a dimension of 37 as well. So if I just give that dimension there, that needs to go up 37, and then the top of this can now join, actually no, I can leave that floating up there a little bit longer. These are all going to sort of connect together in a second, so I can just leave them out the way. And then we need to give this a thickness of 3. This thickness of 3 is going to come up quite a bit, so let's just draw a little rectangle out here, and we can make all these angles so that they're perpendicular, like so. That's perpendicular to that, that's perpendicular to that, and then like I said, this thickness here, this is going to be 3 millimeters. So why 3 millimeters? So all of these pieces that we're looking at that make up the skeleton of this cat, if we get our trusty calipers out again, I just show you roughly on here, these are pretty much, that says 3.4, that's maybe a misread there, it's about 3. I think there's a bit of tolerance with a 3D printer, but we're going to worry about tolerances a bit later on. We're just going to look at modelling the thing first of all. So 3 millimeters is the thickness of all these pieces, so that's going to be important. So that's 3. Then we're going to have another couple of parallel lines, so I'm just going to draw some parallel lines there, so make them parallel to each other and make them parallel to that piece there. And that is going to be, the distance between that and that is going to be 11.5, and it's 11.5, and if I think that needs to be 11.8, or should we just call it 12? Let's just call it 12. It's basically the thickness of the servo, because that's going to be the servo in between there. And the distance between that and that is going to be 3, which is our thickness. So we just need some lines between those two, and we just need to make them perpendicular as well. So let's just grab that and that, and let's just zoom in there. Yeah, we didn't actually draw that line. Alpha line between those 2 points, and I'm just going to click on that line there, make that perpendicular to that one, like so. And then we're going to make it that collinear to that one. So that line there needs to be collinear to that one there. And if we just zoom back a bit. Oops, I did the wrong zoom then. I knew I was doing that wrong. Right, zoom back. So let me just go back to the main view there and then back to the front. There we go. So I just need that last one there, that line needs to be collinear. That line needs to be collinear with that one there. So let's go to collinear, that line and that line. Okay, perfect. So this gap in between here is where our servo is going to sit. And the top of that point there, that is the top of this rectangle here. So we can actually make this, if I just grab that line there, click on the coincident with that point there, that is the dimensions for that particular rectangle now. And we can just make it stick to the origin. So I'm just going to draw a line from the origin. In fact, we've got a line there. If we just make that line the midpoint on that line there, then that's perfect. So it's still blue at the moment because this hasn't got a height yet, and that'll be defined by these 2 pieces, which are the legs. And we can start putting these legs into place now that we have a servo up here, because we know that there's going to be a pivot point on that servo, and then there's going to be this servo here that this pivots to. So let's just zoom in a bit here. So the way that this is going to work, I'm pretty sure on our Yeah, pretty sure. On our servos, if we have a quick look at one of these, you can see the, let's get my pointing stick here. The very center point of that is 2 concentric circles. So all we need to know is what the diameter of that is and make it so that it's concentric to the outside circle. And that'll give us the pivot point that we're after. So again, I'm just going to draw a circle just over here, and we're just going to make that tangent. So make that top one tangent to there, the bottom part tangent to there, and then this wall tangent to, we need a line to make it tangential to, so let's just draw that in, and we can just grab it a little bit. Oops, let's just move that over there, and let's just draw our tangents again. So tangent to there, and then that is tangent to that top piece, and then that line is tangent to there. Why is it not grabbing that line? So I'm just going to hide the dimensions for a second. I can see that that line just hasn't picked up. So that line needs to go from there to there, and then we need to make that and that tangent. There we go. Okay, so then the center, the concentric center that we're after there, we just need to know what that is as a diameter. I'm pretty sure it's about, I was going to say 5, yeah, 5. Pretty much bang on 5. Just trying to show you that on there. So you can see that's pretty much 5. And that's this little white piece that's in the very center there. Okay. Oh, somebody said can't see your screen. Yeah, sorry about that. Right, so where did we get up to? Somebody can just tell me, where did I stop showing you the screen? So what I've done there is I've created these 2 rectangles, and they're going to be like a sandwich. In fact, I can show you what they're going to look like. So they're going to look like this, which is 2 pieces. They're going to have an interesting kind of profile to them, and then sandwiched between them is going to be the servo, and that's kind of what we're modelling at the moment. We're kind of modelling it in that orientation there. I'm going to have to watch that screen bit there. So we've got a circle there which is 5 millimeters in diameter. We can just put our dimensions back on. We have 2 rectangles at a 45-degree angle next to each other, and we have a circle within that which represents the sort of circle of the this part here on the servo. And then in the centre of that is the white spindle. So the reason we needed to do that is because that is an important pivot point. It's going to be a joint slightly later on when we join these things together. And what we then need to do is get our top leg here, and we need to create a circle within that as well. We need to do the tangential thing where we grab the tangents to make this nice and joined together, like so. And then these two are going to be coincident like that. And that's how these things are going to pivot. I need to just make sure that is 100% correct. Yes, it is. That's fine. Perfect. So let's just zoom back a bit. And once we've got this, we can then start modelling out these other pieces then. Just need to grab my hand tool just so I can move that right. So this bottom leg here, so at the moment, yeah, so this can move up and down, which is fine, and that's tied to the ground. Perfect. So we just need to know whereabouts on here the other pivot point is, and this is a kind of mirror image. It looks like a kind of a bone shape. So you can see there both pieces around, and the pivot points are exactly the center points of them. So if we just draw another circle here, do our tangent thing, then we should be golden. So I'm just clicking the edges with the tangent tool, clicking that bottom edge with that one there. So that's now nicely positioned. And then if we just make these 2 points coincident, so that point and that point, boom, there we go. So that is the very basis of our skeleton. That's as little as we need actually. So I'm just going to finish that sketch there, and we're just going to zoom out. So what we'll do first of all is we're going to model one of these, what I call the collar pieces. So what we need to do is we just need to grab that profile and just make sure we grab all the pieces, because sometimes it misses that out. And we're just going to look at that in 3D, and we're going to push that out by I think it's 75. So 79, let me just check. So I think that is 79. So let's just do 79, like so. Let's have a look what that looks like. So it's got this sort of rectangular plate which is at 45 degrees. So what we're now going to do is model this piece. This is the collar piece which sits either side of the servo there, and this is at the 45 degrees, and we actually have two of these. So once we've created one, if I just go back to the main camera, I will remember to put it back onto the Fusion 360 screen, I promise. Right, so if we have this here, these collar pieces are actually going to be across here. It's kind of this piece that goes across here and also on the back as well. So on this older version, the servos just kind of slot in there as a solid piece, whereas this you just print out essentially 4 pieces which are identical, and then there's this round piece, the shoulder piece, that they all snap together with. But it's really, really solid when you put them together, and I like the fact that there's no screws or anything for those pieces. It's just a sort of a push fit. So that's what we're going to be creating, this interesting profile. So let's get back over to Fusion, see I've not forgotten this time, and let's create on here a new sketch. So let's just do that. Let's just make it fill the screen so we can see what we're doing. And what I usually do with this, I'm going to project in the whole body so that we've got some nice edges to snap to. So if I just press P for project, and you can either do specific entities or body. So I'm just going to click body, click OK, and what that's done is it's given us these points and these lines that we can project from. So it's an interesting shape, this one, and it's got some interesting cutouts too. So if we look at this here, if I get really close to that, you can see there's 2 little notches, top and bottom, and them notches are what the shoulder piece is going to push into. So we have this shoulder piece that we're going to model in a second. I'll show you that. So this is going to push through there, like so, and then it's going to lock into place there. So if you can see that, that's quite difficult to show you there. So it's going to push through this little gap, and then it's going to push to this the outside there, and there is an exact mirror of that above, and that's where the servo is going to sit in between, just like so. You can just about see that in focus there. So let's get to this. So let's just draw a center line first of all. So if we just go down to the edge, we'll see we've got a little triangle, which means that's the center point. I'm just going to make that construction by pressing X, and then we're going to draw a couple of lines going straight down, and then we're just going to measure from the edge for a couple of these. So that's not quite straight, so let's use the parallel tool, and then from the edge to here, that's 4 millimeters. And between the next one and that one, it's going to be 1 millimeter. So let's make them both construction lines for now. And I'm also just going to bring them down to the top there so that they lock into place, like so. Okay, and what else do we need to do there? So then we need another 2 on the other side. So let's just draw another 2 lines. So they're also both going to be X for construction. They're both going to be connected to that bottom bit, and they're going to be also a millimeter apart. So let's just do D there between those 2, and that's going to be 1 as well. And then the distance between we can either do the distance between these 2 as being 3, which is our thickness, or the distance between the outside being 5. Let's just do the 3 for our thickness there. Okay, and then let's draw a line across here and another line across about the top there. Let's click on them and make them nice and parallel, not parallel, horizontal, and let's press X to make them construction lines. Okay, so what we need to do is we need to draw a nice arc between 3 points. So what I need to do is give a distance between the top and the bottom line that we've just drawn. So if I just do D for dimension, hit those 2, that should be 23. I wasn't far off there. And then from the top, that's going to be 5 millimeters from the very top. So let's just do that. Okay. Okay, and let's just move them to that edge there so they lock into place, similar with that over there. And then what we need to do is we need to draw a line between those two pieces, sort of bisecting it. So we can do that by just drawing out a line, doing D for dimension to that point, and then clicking that dimension that we've just done, divide by 2 to give us a nice midpoint. And let's just move that there, and then that's also a construction line. I don't think that quite took that, did it? There we go. Okay, I think we're nearly ready to draw. Yes, we are. So let's get our create arc, 3-point arc, and we're going to go from that point to that point, and then we're going to use that point there. Now we do need to mirror these things across in a minute, so I'm just going to do one side and then I'm going to apply a mirror modifier to bring all those things across. So now that we've got that, we need to draw some other lines. So let's see how's best to do this. So that's going to be 2 millimeters from the bottom of that line. So if we go D for dimension, there to there, that's going to be 2. And let's just do X for construction line, and let's just get those points just on the edge there as well. Makes it a bit tidier. Move that so we can see it. And what do we need to do there? So right over here we need to start drawing out a bit of a profile. So I'm going to press L for line. We're just going to draw out a bit of a shape like so. And that's that on that bit. We can go down to the bottom now and do the same. So we need to do that and that, but then we need another line there, which is also, let's have a look. So that's 2, that's 27. Right, so I've done one of those dimensions slightly wrong, but this is what's great about parametric modeling. You can just go back and tweak it. So that instead of being 23 should actually be 27. I just tweak that there because it's all parametric. It finds what it needs to there. It's going to check that that's right. Yeah, that's just the center point of there. I'm looking at that and now that doesn't look right. There should be a great big space at the bottom there. I'm just going to look in 3D and see. Yeah, so 5 to the bottom. Yes, that. So that dimension there is incorrect. That should be connected to that bottom line there. So I'm just going to delete that for a second and then grab the correct one and do that as 5. There we go. Perfect. That's it. There should be a bigger area at the bottom than there is at the top. That's what I was looking for. Okay. So what we need to do now is just have another line just going across here. So if I just zoom back a bit so I can see all parts of that, just going to draw it across. I'm going to click it, X for construction, and just make sure it's horizontal, which it already was. Just connect that up there, and then that is also going to be, that's the one that should be 23 between that point and that point there. So like so, that should be 23. So now we can carry on with that little profile that we're creating. So L and there, and then from there to there. Perfect. And what do we need to do next? We need some more curves. So we need to find the midpoint of here and draw a line up. So let's just go until we find that triangle up here. There it is, straight up. Do X to make it construction. And have we got enough to do that? Not quite. So we need another couple of lines going down, one going down there, and another one going down about there. So these are about 9 from each other, so from that line there. That should be 9 millimeters, and then that one should be also 9 millimeters. Okay, just do X again to make these construction lines. Okay, and then we'll just bring that one up to the bottom there, and then up there as well. Now we can draw another one of these nice arcs. I do like these, they make really appealing looking designs. So we're going to go from that point to that point and then just bring it down to there. And I think that's it. Yep. And then we need another one from, let's do a 3-point arc from there to there. Now, where is the point we're going to do? Now, if you look, it sort of sticks there because it's tangential. It creates a really nice curvature, so it knows how to interpret the two pieces there. So you can see that's coming together now. We're getting this nice kind of shape appearing there. Okay, so we do need to have in the middle of this the area where the servo is going to sit, which is just a rectangle. And the rectangle is going to be, let's do 12 across, and it's going to be 22.5. I think it was 23, really. That'll do 23.5. So then we need to just anchor that in the middle. So the way we can do that, sometimes I like to sort of pull these things off to the side here so that we don't get it snap into anything that we don't want it to. So I'm just going to draw a little crosshair in the middle there, just so we get a center point. And I like to draw a little point in the center as well. There we go. And then I'm just going to make those two construction. Right, so this can now go back over here, and the very center there I think needs a point as well, so let's just draw that in like so, and then we can just click that point, make that coincident to that point there. Let's just try that again. Oops. It's really not like wanting to do that, is it? Let's just put it closer to it, coincident to there. There we go. Phew, that was a bit of more trouble than it should have been. Okay, so what do we need to do next? So we do need to draw some tiny little circles. So these servos have got some holes in them where we attach the screws. So if I just show you that, these top and bottom holes is what we want to draw a circle so that when we put the screw in, it's got something to screw to. And I found that 1 millimeter is about the right dimension for these. So let's just do that as 1. And let's draw another one somewhere else just down here. Oops. So C for circle and D for dimension. And then let's just make that 1 as well. And we can make these both aligned to each other by hitting this horizontal vertical tool. If we do that, they're now sort of, whenever you move one, it moves the other one as well. And then I think for the distance between them, I've got this as being 28.9. So let's just do that between that point and that point. 28.906 it actually says. Let's do the same there. So that's great, that's where they're going to be, but we want that to be precisely equidistant to the middle point. So again, the way we can do that, we can just click on that point, click on this center line, and then we get a dimension appearing, and then we can just click on the distance between both of them, which was that 28.9, and then just do divide by 2. And then if we align that, snap that to the center line, we've now got them screw holes perfectly where we want them to be. Okay, we're nearly done with this piece now. Good. So let's just move across here. We need to draw a nice arc on the bottom piece there. And the way that I'm going to do that is I'm going to draw 2 lines. Let's just draw a bit of a shape actually. And I'm going to do D for dimension. That's going to be 40 across. And between that middle point and that one of those edges just needs to be half of that, so that it centers it. And let's just bring that up to there, that up to there. And let's make the whole thing construction lines by pressing X. This is important when you're doing profiles. If you don't put them as a construction line, it makes it quite fiddly to try and pick them out later on, because when you select the profile, it tries to look for solid lines and it ignores construction lines. Right, so what we can do now is we can create the arc that we're interested in. So let's go for the 3-point arc, and we can do it between those 2 points and that bottom piece there. And then we just need a line that connects that piece to there, like so. Now, like I said before, we can actually just mirror across the pieces that we're interested in. So let's try that out. So I'm going to go to Create and Mirror. And then it's going to say, what is the mirror line? So let's just select that center line there. And then the objects that we want to mirror across, and you can start to see them appear on this right hand side. So I'm just going to pick these one at a time. Hopefully be able to pick all the pieces we need. So I'm going to have to just zoom in to get that piece that's just there. And so, like so. And then we just need to move the bottom piece up to do the same there as well. Oh, did I just unselect that? So the mirror is actually something that you can find if you go back to, if I just move that hand, let's just find the mirror, which is, I think it's all these different lines there. Actually, we can just carry that on. There's only a few pieces missing there. So in fact, we could probably just, could we eyeball that? No, let's just mirror that across. Back to create mirror. And again, let's just select that center line, which is there. And then we want these couple of pieces. So that one, that one, that one. And then these two small pieces. That one, that one. And let's see what that looks like. And then that piece there. Okay, has that completed? I think there might be one tiny piece missing there. And we can just draw that in, that's fine. Okay, so that should be our complete profile now. We don't need to draw in them other pieces just yet. I've not got to, so there's some holes in here which are used for attaching some of these pieces, but I'm not going to use them in my design. We're going to come up with something different for that. So I think this is fine. I'm going to finish that sketch. And we can see now, what I was saying before about it ignores these construction lines and it just looks at everything that's within that profile, and it knows that it's a complete profile because it turns that colour there. And what we want to do is basically just extrude that up by the thickness, or because it's already got 3 thickness there, we actually want to push out these pieces. So if I just select the pieces that we want to push out, press Q for push pull, and then just select the pieces that we want to push out, and we're gonna go that way, which is to push down. So let's just say, instead of distance, all, and we're just going to say OK. I forgot to select the middle bit, so we can just go back to that, double click it, and also include that piece too. And also we just need those 2 little holes as well, that one and that one. There we go. So that's the first thing that we've created there of our cat. So we actually need to replicate that 4 times. We need, well, 3 extra times. So we can do that in a moment. Let's have a see where we're up to on what we need to do next. Yeah, I'm not going to do that just yet because we don't know where it's going to be in space. We don't know what the distance is because we haven't actually modelled out the shoulder piece yet. So let's do that shoulder piece next. Now this is what I mean about the top-down, bottom-up design. We know that there's going to be this shoulder piece, which is this round section, but we don't know where to put it. And I know that it's going to sit, I'm going to create a new sketch on that plane there. And that means that we know exactly that this is in the correct area. So let's just create a couple of lines. We're going to be working at a funny angle here, so that's okay. We just make these perpendicular to each other. Like so. Excuse me. And what we also need to do is just project in. So I'm just going to move the 3D image slightly just so we can see which ones we should be selecting there. So I want that point there, for example. So I'm going to press P for project, and we're going to select, let's just zoom in, not the body, we're going to do the selected item. So I want that one and I want that one. And I want the same on the other side. I want that one and that one. That's what I'm interested in. Okay, so if we go back to the front view now, we can see that is where the cutout needs to be. Okay, so let me just scroll down. Oops. Right, okay. So let's just draw some dimensions around this. So this piece here at the bottom needs to be 40, and this on the side here needs to be not that angle, it needs to be that angle there, and it needs to be, I can just find that on there, 30.5. 30.5. There we go. Okay. And so that's a little bit larger than the piece, which is correct. That'll become obvious in a minute why. Because this is going to be inside of this this shape. So now that I've got there, I can actually create an ellipse shape now. So if I just go to the midpoint on here, which is there, draw out a straight line to there, and then just draw, oops, that's not right. Let's try that again, ellipse. I'll place the center point. Right, so to do the center point, I need to do a line from there down to there. Let's make that construction line, and then just one again from the middle, X to make that construction line, and now we can go back to our ellipse. And we can start from that center point and then just draw out and then up. Perfect, that's what we're after. And then what the next thing is, we need to create 1, 2, 3, 4, no, three sort of rectangular shapes. So let's just sketch these out roughly what's going to happen here. So we need one main one, and then we need some smaller ones which are going to sit within that. I'm just drawing them out really wonky to begin with, and then we can straighten them up in a second. Like so. Right, so that needs to be perpendicular to that one there. That needs to be perpendicular to there, that to there, that to there, that to there, that to there. I think that to there. Right. So let's draw some dimensions on this. So these are the cutouts that the pieces are going to cut through. So they need to be 3 millimeters thick. So I just need to get that one there, make that 3. And that's the same with this piece here. That also needs to be 3, like so. And then this larger piece, what we're saying, that's going to be 27.5. So let's just grab that, make that 27.5. And we want that to be pretty much centered on this piece here. So we can use our trick that we did before. We find the center, we find the edge, we pull it up, and then we just divide that one by 2. And that gives us a nice centering. It's now just floating around there. So so in a minute we're going to be able to connect it to this piece that we've got this point here, but we're not quite there yet. So what we need to now do is we need to create these 2 boxes need to be equidistant to each other and aligned to this center line. So they need to be 9.25 apart, I think. Is that right? No, the centers of them need to be 9.25 apart, right. So what we're going to have to do is draw a very center point from there to there. Make that a construction line, and then we need to do the same with this next one here. So let's just do a line from the center of there to there. Sometimes it's easier as well to switch off the bodies. If they're sort of getting in the way, we can switch that off. Sometimes the profile can also get in the way, but at the moment it's just all these crazy dimensions. And yeah, let's turn the constraints off for a second. I think they're not helping actually. And what we also need to do, we can make these edges collinear. So that line there is collinear to that line there, wherever that's going to end up being. And that line there is similarly collinear to that one there as well. Okay, right, so we've got these 2 lines, and what we're saying is those 2 center lines, make that one construction line, if we just find there, they should be 9.25 apart. Okay. And what they need to be 9.52 apart from, oh, I've done that to the wrong one there. Let me just delete that one. It's to each other. That line to that line, 9.25. There we go. And what we need them to be equidistant to this center line, so we can use our trick again from there to there is that divided by 2. D45 divided by 2. There we go. So they're now locked into that center line, and what we need to do now is just sort of say how big they are. So let's have a look on here. So they need to be 28. So if I just dimension one of these as being 28, and what we need to do is make that centered to this center line as well. So again, we can use our trick with that line to that line there. That's going to be half of that 28. Okay. So why has that gone right over there? That looks crazy. So that's 28 across. Why has that gone to 1 there? That shouldn't be 1. So that should be that line there, divided by 2. That's it. Don't know what had happened there. That looked very strange. So 24. Right. So this middle one here, that shouldn't be. That should be 24. That looks more like it. I don't know why that was incorrectly set there. What was I looking at there? I was looking at the edges of these, I think, that edge to that edge. That's fine. But again, because we've used these tricks to make things half, everything fits into place when we... let me just sign back into my other account there. I don't usually use this machine to do this with. I usually use my iPad, but I forgot to bring it up. Good grief. Let's try and type in this massively long password that I came up with when I got hacked once. Is that right? Can't remember if that's the right password. Yes, it was. Yeah, I once got hacked. Somebody had hacked into my EA Origin account, and I managed to track down through some stealthy stuff who they were, and then I basically just said, if you don't give me my password back, reset it to something that I know that is, I'll be sending the police round, because I'd spent quite a lot of money on EA, on all the different games. Like my daughter has all the Sims 3 and Sims 4, like all the packs. And that must be a couple of £100, if not into the thousands. So yeah, the person that they had a VK account, some kind of Russian social media account, and they used the exact same profile picture on the one that they'd hacked my account with. So I was managed to sort of do a reverse image search on the internet, find their IP address, and then talk to them in no uncertain terms. Right, I think this piece is ready to go now, so I'm just going to do finish sketch on there. What we haven't done, let's go back to the sketch, so just edit it. We haven't locked it in place to them points, so let's just go back to our constraints. We want to see that original body that we hid before, and we just want to lock this in place. So this little corner here needs to lock in place to that corner. If I can just see it a bit better, maybe if we just spin round in 3D, we can see it a bit better. Right, so this point here needs to be collinear to that, coincident to that point there. Let's see if we can get it to do that. So that point there. Come on. Try that again. That point there needs to be collinear to that point there. Why is it not happy with that? Let's just go back to the front. It does seem to have locked that in there, doesn't it? That's not good. I'm just going to do undo so I can move that around. Yeah. Right, so it's using that as a pivot point for some reason. Is it that one? Nope. Which one is it? Is it that center one there? Just want to make sure I'm not undoing the wrong one there. Yeah, I think it's that triangle one. That looks wrong. Right, there we go. So what I want to happen is I want just zoom back. Ah, right, that's completely messed up there, hasn't it? So they need to be... Oh, good grief, what's happened there? So that's sort of become unskewed to there. Well, we can lock that into place. That we know that that point there needs to be that point there. So let's just try and get that to be correct. Like so. And then we can figure out what on earth's going on with this other piece here. So why has that gone wrong? Now we probably just need to lock it as well. So let's find... Let's just zoom in down there and just move it into place. So... Is that possible? Can that be? Let's just make that parallel to that one there. And let's just have a look and see what's going on there. So this whole piece here seems to have got locked in place. Just thinking what's probably best to do. Do we just delete that piece and start that bit again? So that should be the 30.5. I wonder why it's forgotten that dimension. And then this piece here, let's just delete that. If I delete these pieces, is that going to mess everything up? No, it doesn't seem to be. Right. Okay, let's just draw that last rectangle out again. So we can just do it wonky and then straighten it up. And then that's probably all that we're going to get through in this particular session. We might be able to just extrude them out and assemble them up quickly. But I think we're quite rushed for time. It might even be in a 3 or 4 part of this one, actually. What on earth happened then? Let's just go back. So that needs to be tangential to that one there. That to that one there. That to that one there. And that line need to be parallel, like so. And then we can make that one there. That line there needs to be 30.5. It doesn't matter how much prep you do for these things, it always seems to go wonky. And then we need to do that as being 40 there. So I've literally drawn out next to me every single step of this with all the measurements on, but when you do it live it just seems to be a different story. So what's going on there? I'm just going to turn off them dimensions and them constraints so that I can see what's going on. Right, so let's just put the dimensions back on. So I want that line and that line to be that divided by 2, and we just need to then draw a line in the centre, down there, press X to make that construction line, and then we just need to do the same again from the edge there. So that one to that one there needs to be 40, which seems to be okay with. So if that looks right, it doesn't look right to me though, that. So this needs to be the one that's that divided by 2, and then that centre point of that line there. So let's just do that distance from that line to that line needs to be the same as that one, is it? No, that 28 divided by 2. Right, okay. I think that's now locked into place. Yes, so we can just do that ellipse again. So ellipse is just from the centre point to one extent to the other. Is it happy with that? If it is, I think we have our profile. No, the height of that's still wrong, isn't it? So that needs to be so the whole that needs to be 30.5. So this should be smaller than that. It should be 18.5. So that one should be 18.5. Sorry about this, folks. Completely got that one messed up there. And then we just need to do that from there to there, which is just half of that 18.5, like so. Okay, is that all centered up? Just wondering why that's blue. That profile looks correct now. Okay, I'm happy with that. Yeah, that looks good. So then what we then need to do is just press Q, pull that towards us. So let's just grab hold of it by 3. Now it looks like one of the measurements is slightly off somewhere, so we can see there that's not quite fitting as it should do, which probably means I've got this one incorrect. So I'm just going to go back to there and have a look what that actual sketch measurement is, and why that could possibly be incorrect. So it says that that's 27, and I think I put a different measurement for that. It's between that and that one there is 23. So let's just go back to that other one and see what that looks like. So we've got 28 there, so I wonder why that's 23. So 28 for the extent. So did I have that as 20, 27 and a half. Yeah, I think it's to do with either the heights of these things, which I've got on the other screen. We can basically just tweak them up, but you can see there's a bit of a mismatch. I just need that to push down by a couple of millimeters. So without going into that correction just this time, what I will do is I'm going to copy this piece and I'm going to make it so that it's in that hole there as well. So we can actually correct the base one and it'll flow through to the copied version. So if we just select the body itself, and we can give these proper names as well. So that piece is called shoulder, and that piece there is called I call it the collar. I don't know if that's the right term, but essentially we need to copy that collar. So I'm going to press M to copy it. I'm going to do create copy, and then I'm just going to move it out over here for a second, because what we're going to do is we're going to create that join. And what I want to do is I want to find a point on here. So it's probably going to be, we zoom right in, this corner piece here. So if I do joint, so you have to join components together, not bodies. So that's what it's complaining about there. So what I'm going to do is make each of these a component. So let's just do that. What happens is you get these separate components. They have their own origin points and their own bodies. That's the difference there. Okay, so now we can go back in there. We can click on the joint. We can get a better view of the surface that we're looking to join to, that one there, and it's just this point here. So you can see it's moving around. If I press the command key on the Mac, I think it's the Alt key on the Windows, you can see it sort of stays on this flat surface, and I'm going to put that coin just in that area there. Right, so now what we need to do is just find where we want that to join to. And just flip the model around until I find the piece I'm interested in. So that coin is, you can see, just there. So that corresponds to that point there. So if I just zoom in, select that one. Not quite got that right, so I'm just going to do that again. There we go, just flip it over. Is that right? That doesn't quite look right to me. So do we need to flip it around 90 degrees? There we go. Is that right? Oh no, that's completely off. So let's just undo that. Let's just go back to that joint. It wasn't just that orientation, it's completely on the wrong orientation altogether. So let's just cancel that. So what was I doing wrong there? I was going for that one. I'm like completely upside down there. That's what's not helping. I'm just going to quit that one as well. Let's just go back and start again with this. So what I'm trying to do, I'm trying to get that top edge there to be in that top edge there. So let's go for that top edge there. I always do it inside that one there. So let's go for joint, and that'll do. And then the joint, so it's the inside edge, it's going to be it's just difficult to picture this in your mind's eye, and then if you get it wrong. So I think it's that one there. I think it's that corner there. And it's just trying to flip the whole thing around so you can actually see it. I think it's that one there. There. So let's just go back to that. Is that right? Nearly. It's that one there, isn't it? Right. There we go. Okay. Let's just press home because we just flipped out there. Oh, for goodness sake, Kevin, what are you doing? We're going to go for that one, bottom one down there, and it's going to be that side. Right. So let's cancel that. Why can't I get this right? Why can't I get this right? What am I doing wrong? Right, let's just start that one more time. We haven't actually joined the other one, so I want that corner there. If I just move this thing out of the way completely, let's just press M and just give it a bit of a move out of the way. Okay, so I want... I go for that one again in there, so it needs to be that top back edge. Or we can do that edge there. Let's go for the top edge in there. Because I'm conscious there's like 15 people watching me. So let's go for that edge there. Right. So that's the inside there. So when that flips round, it's that back edge. That's going to flip round, and that is going to bite into there. That bite point, just get this in my mind's eye, which is there, is going to bite into it doesn't help this isn't in the same orientation. I think I'm going to flip it around a bit. Let's just do a bit of a flip. Like so. Right, that helps. That helps. We're nearly there. And then it doesn't actually matter if this is the same orientation. I think I actually flip it on the other one. But anyway, let's just assemble it and we can see what we're doing there. So let's do that point to that point. That's probably the easiest one. Let's do the center of that one to the center of the other one. So let's just capture that. Let's just the center of that to the center of that one there. That's probably the easiest way to do it. Yeah, whatever. And then why on earth has it come through at a funny angle? Good grief. There we go. That'll do. That'll do. And now it's complaining that there's another joint there. What are you complaining at? Select your joint type will result in... Oh, come on Fusion. What am I doing wrong? Let's just delete that joint altogether and then let's do that again. Because now we know what we're doing. Right, we want to get that joint there to be that joint there. And then for some reason it's doing it at an angle. Why is it doing it at an angle? Why is it doing it at an angle? I don't know. Let's just straighten it out. Minus 45 degrees. There we go. And it doesn't like that. It doesn't like that at all. I'll give this one last go and then I'm going to give up on it, and then I'll tell you why it didn't work. Let's try that point there. That point there to the inside. I'm sure this is riveting to watch as I just get this wrong again and again and again. Right, so let's just see that there. So that's on there, and that's going to go into that inside piece just there. I think that should be on that top edge. There. Has that worked? Has that worked? That's worked, and then the bottom one has just fallen off. Oh, there we go. It's kind of there. And then it's just complaining. It's got some red error there. I don't know what's going on there. Is it because there's an existing one? If I just delete that, that's fixed that one up. And then we just need to do the same with that bottom one there as well, because that didn't actually have a joint in it. So if I grab that surface there, let's just do that one last one. So let's select. Do I have to select that one first? And then like that. Good grief, Kevin. There we go. That looks right there. That looks right. Ah, right, yeah, right. I'm just completely getting this wrong. This is how these things push together. They're actually connected to them bottom pieces there, not the whole. This is how I've been struggling with it. I've been trying to connect something to something that is in the middle of space. Oh, for goodness sake! Right, was a lot easier than I was thinking. So we just need to do. Let's grab that one there, and then let's grab that one there, and then let's just flip that over. The world's most tedious thing to do this. Okay, we're nearly done. We're nearly done. So that surface there joint is going to be, let's grab that one there, and then let's push that to that one there. That's it. That's all I was trying to do. That's not that hard, is it, Kevin? Right. And then we just need to do the same with the other piece, and then we can actually stick a servo between it. That's what I'm just trying to get to before the end of the show. Right, so let's just do another one there, which is that one there, and then let's grab that one, which is going to be that one there. There we go. Cooking with gas. Right, so what I'm going to do is I'm going to bring in, I have a SG90 that I've previously modelled, so I'm just going to bring this one in. You just right click on it, and we can bring it into the design. Do I need to save that design first? I think I probably do. Right, is it going to let me? It's complaining about that there, so let's just quit that. Let's go back there, let's just grab that one, insert into current design. It's going to appear down here as an extra thing. And we need to do the same thing there that we've just been struggling with for the past millennia, which is just create a joint, rigid joint between the undersurface of this and where it's going to fit into there. I'm probably just going to eyeball this one for now, unless I can come up with a... Yeah, we didn't actually model in the holes for this, and that's what we would actually join the two things together. So without going back there, I'll just show you roughly what I would do there. So I would grab that circle there, and then I would do a joint, and I would join it to on here, where I forgot to model in the little hole, and that would snap the two together. Excuse me, so if I go back, you can see there that would sit in between these two collar pieces and the collar and the shoulder piece itself. And then we've got the this piece here, which is the leg, and then we've got the foot, and we've got the two servos pushing through them as well. They're actually quite quick to model, and we haven't actually done those pieces yet. We can do those next time though. I'll probably do a midweek video so we can crack through this, because what I want to get to is the point where we've created this this cat, and it's fully articulated. We've got all the different pivot points so we can move things around, because when we start looking at things like the inverse kinetics, we'll need to have a model that we can do this with. So before I leave you, I want to show you a couple of things first of all. So the first one is, let me just bring up this, the Critter it's called, and it's another 3D robot that I found. Let me just bring up the screen there, if I go to that one there. So this thing, I can't remember where I saw this. I was probably looking on Thingiverse for 3D printable robots, and I came across this thing. It's just amazing. So it's like a single shell, and it just has 4 servos, I think. So it kind of waddles its way. It doesn't have a back one. It's kind of like half a quad SMARS robot. If I just mute the sound on that one, I can probably play. There you go. So it just has a back piece that it drags along the floor, and you can see there it's quite quick for them to sort of print it out. There you go. How cool is that? I think it uses an Arduino Nano as the main thing, and you can just see the batteries just stuck on the back there. They're clearly not designed anywhere for the batteries to go, but that's going on my list of things I have to print out, because wow, how cool is that? Had to share that one with you. So a couple of other things as well. So if you're enjoying this show, I invite you to buy me a coffee. So as I've said before, there's quite a lot of expensive stuff that goes into putting one of these shows together. We've got the website hosting. I'm going to show you some cool stuff on that in a second. The royalty-free music that I have at the beginning, the graphical elements to like produce the slides and so on. So I have Creative Cloud for that. The streaming software that I use, Ecamm, that's quite expensive per month, and then the camera, which is just ridiculously expensive, and then the lens that goes on top of the camera is the same price as the camera. Check these things out. They're super expensive. So if you want to help me out, buy me a coffee. It means we can keep the show running for another year if we hit our goal. So I've set a goal there for like £1,000. If we can hit that, it means we can carry on for another year, which I'm sure you'll want to do. And then the website. Oh, not the website. Every Sunday we go live at 7 PM Greenwich Mean Time. So you live in the Americas, that's in Canada. On the left-hand column, we've got all the time zones there. In the middle, we've got the sort of European countries, India and Pakistan, and a bit of Russia. And then on the right-hand column, we've got Australia and China as well. The website. So I've done quite a bit of work on the website recently. Let me just bring this up and show you what we've got going on. So let me show you that on here. So if I go to smarsfan.com, what's this? There's a little PicoCat thing peeping out here. Let's just make this a bit larger so we can see what's going on. So yeah, there's a little PicoCat. If we click on that, we've got a new set of pages. So some of these are being constructed. The design studio, there we go, a nice graphic for PicoCat. And these are the ones I was following then as we were progressing through this. So all the dimensions are on there, all the different profiles, all the different steps required. So this isn't complete yet, but as I go, we will add to this. So you can see there all the different profiles coming together, and all the different steps required, all the different measurements to make this thing happen. So that'll be the midweek video. It'll be me carrying this on and getting some legs and hopefully the head. That's the fun bit. It's such a clever design. Where's he gone? Where's he gone? I had him just off camera a second ago. I can't find him now. I want him. There he is. So this is such a clever design. It's made up of quite a few different profile pieces. So this sort of side profile, and we can design all this parametrically. I have done this. There's the sort of ear shape. There is the I call it the eye mask piece there. There's a little nose piece as well. And then there is this sort of chin piece that keeps everything together. And when we push this servo through, there is no screws holding any of this together. It's just all cleverly designed. So again, I'm going to have to find the name of the person who designed all this, because this is just genius stuff. But I've enjoyed parametrically measuring all this out and putting it into Fusion 360. So we will get to that, I promise. We will definitely get to that. What else is that I wanted to talk to you about? I'm sure there was another thing. So let me just get my notes up. So we talked about, yes, so in fact, my post-it notes here, so I've got my Buy Me a Coffee one. We've talked about PicoCat on SmarsFan. I think we looked at everything that was on there. Oops. We looked at, where's it gone? Where's my Safari gone? There we go. I've lost my screen now. There we go. So yeah, we've looked at the design pieces. So we're also going to have on here some build instructions. I've not put them on yet. All the electronic components that we need. The modules, and this is where I think we're really cool from the community to sort of start designing pieces. So once we've finished the Fusion piece, you'll be able to take those STL files, those Fusion files, and start modding it yourself and creating your own versions of that. So this is something I'm really looking forward to. As we design these pieces and save the STLs, we can have them on here. We've got the videos, which I've started to put together. So if I just make this a bit larger, we can see, hopefully, just wondered why they're not aligned there. Yeah, so we've got the YouTube videos. Literally just click the link to start the video. We've got one on the Raspberry Pi Pico. We've got the Raspberry Pi Pico OpenCat and MicroPython, which we started with. We've got that one about VS Code, which can help us write some really cool MicroPython. We have the rangefinder one, which is the eyes of the cat. We did a video on that. We did one on servo easing. I'm really looking forward to implementing this in our cat. And then we've got the one today, which is the cat itself. So, or the beginning of modelling the cat in Fusion 360. So I'll keep these videos updated there, but you can find it all under the PicoCat on smarsfan.com. So that's that one. And then the other thing I wanted to show you, so we do have a new Facebook group. So if I go to Facebook/groups/small robots, I don't know why it's got all that stuff at the end there. Let's just get rid of all that. Let's get the address. So small robots, like so. And we go into there. This is the Small Robots group. We've got 574 members. This thing is rapidly growing and there seems to be more members joining all the time. So if you're not a member of this, join this group. This is where we're going to start talking about all those things. Things like the that robot that we looked at last week, whose name I've forgotten now. Was it Vika something or other? That critter one. We've got Smars, obviously. We've got Auto DIY. We've got the OpenCat. All the small robots, all the things are going to be in this group. So you can see there we've got all the members sort of joined up there. I can see Camillo, I can see a couple of people that I recognise there. So yeah, you can see that the video is live because I pushed these out to that group as well. You can see the Smars robots there too. So that's the group to join. I would like people to sort of join me in that one. And obviously we still have the Smars community group as well. So if I go to that one, that's also where we broadcast to. So you can see me there sort of showing off there. It's a couple of seconds behind. So yeah, if you're not a member of the Smars community, think about joining that one too. So yeah, that's the notes I've got to talk about, and the critters one, I've talked about that one as well. So I think that's everything I wanted to cover off in today's show. Like I said, think about buying me a coffee if you can help out with the show. Definitely join the Small Robots group and the Smars community. If you're watching on replay, definitely leave a comment. Give me a like if you like the video. If you don't give me a like, give me a thumbs down or whatever. And certainly subscribe if you can. So that always helps out. If you can press the big subscribe button, that helps you know when a new video is coming out, because I do them regularly on Sundays, but the midweek one can be a Thursday or a Tuesday or a Wednesday. It just depends on what else is going on there. So if you subscribe, you'll get to know all those different timings of things. So yes, I think that's everything for today. I'm just going to have a quick look through the comments to see if there's anything anybody else had mentioned while we were on the chat. Yeah, there's quite a few comments there, so let's have a look through and see what people have said. So Uday was saying he's from Germany. Hey Uday. I've got Jacob. Please share the link of this video. Absolutely, yep. I'll share all the links. If you look in the description below, you'll be able to find a lot of the links as well on YouTube. I think on Facebook I do include some of them in the event description. A few people saying, can you switch your camera to Fusion 360? Yep, I'm an idiot. We've got Ovi there who's working well on his robot. He sent me some videos this week of his robot moving around the floor. So that was pretty cool. So you were saying what software I'm using? That's called Fusion 360 by Autodesk. There is a hobbyist license which is free. As long as it's not for commercial usage, you're fine with that. I'm looking to get the commercial version of that very soon. That can be one of the things that people, if you buy me enough coffees, if I can get a monthly subscription for that going, that would be cool as well. So Thomas says, looks like reconstructing is faster than copying. And the list is getting longer there. And the coffee is on its way. So quite a few people generously donated coffees as well. Again, that really helps me out. I don't want to talk about that too much, but I don't ask anything else of you guys, so that's really cool. I love the fact that we've got 15 people watching there. I can see on the stream deck that it says that's the number that we've currently got. So thanks everybody for watching. I'll see you next time.